In this presentation, we will discuss one application of linked list, that is polynomial arithmetic. So let's get started. Before starting off with polynomial arithmetic, we must know the definition of polynomial. We must know what is a polynomial. The word polynomial comes from poly, which means many, and nomial, which means terms. It should be very clear that polynomial is the word which is composed of two words. One is poly and the other one is nomial. Poly means many and nomial means terms. Okay? So it is clear from this fact that polynomial is an expression with many terms, right? Apart from this, each term of a polynomial has a coefficient and an exponent. It should be very clear that each term of a polynomial has a coefficient and an exponent. For example, we can take this polynomial 5x cubed minus 3x squared plus 2x plus 1. This is a polynomial. Here you can see that we have four terms: 5x cubed minus 3x squared, 2x and 1. These are the four terms of this polynomial and they are added together, right? Now let me tell you that in this polynomial, this is an exponent, okay? And this one is a coefficient, okay? So it is clear that each term of the polynomial has a coefficient, this coefficient, and an exponent, okay? Now, each node of the polynomial will represent the term of the expression. Now let me tell you that when we are representing a polynomial using a linked list, then each node of the linked list will represent the term of the polynomial. Let's suppose that we are talking about this polynomial 5x cubed minus 3x squared plus 2x plus 1. I want to represent each term of this polynomial using a node of the linked list. For this purpose, I'll declare a struct node with these three fields, okay? These three members of this struct node. One is float coefficient, the other one is integer exponent, and third one is obviously the link part. Let me tell you, we are talking about a singly linked list, and in this singly linked list, we have three fields. One is coefficient field, other one is exponent field, and the last one is link field. Obviously the link to the next node, right? So basically, the first term of this polynomial could be represented by this node, which consists of the coefficient, the exponent, and the link part. This is the node of the singly linked list. Here you can clearly see that the first part is the coefficient. We know that this term has a coefficient 5 and an exponent 3, and that's what we are storing here. There is no need to store the variable x, okay? But here we will store the coefficient as well as the exponent and obviously the link part so that we can store the address of the next node, right? Now, minus 3x squared can be represented by this node. We will store minus 3 because coefficient is minus 3 instead of plus 3, right? And exponent is 2, so we'll store 2 over here. That's it. Now, how do we represent this particular term? We can represent this by using this node. We must have a coefficient over here and an exponent. You know that the coefficient is 2 and the exponent is 1, let me tell you. There's nothing given over here. This means that the exponent is 1, right? So we'll store that exponent over here. Apart from this is just a constant, right? How do we represent this by a node? It is very simple. Here, in the exponent part, we just have to store 0. And in the coefficient part, we'll store 1. That's it, right? So, the polynomial, that is 5x cubed minus 3x squared plus 2x plus 1, can be represented by this particular linked list, okay? I'm assuming these addresses 1000, 2000, 3000, and you can see over here that I'm storing these addresses. Here you can see that first term is connected to the second term, and second term is connected to the third term, and so on. And this is how we will represent a polynomial using a linked list, right? We have a head pointer pointing to the first node as well, and this is important, right? So this is how we will represent a polynomial with a singly linked list. Okay friends, this is it for now. Thank you for watching this presentation.